Good day, everyone. Our topic for today is to illustrate the center radius form of the equation of a circle and determines the center and radius of the circle given its equations and vice versa. Once again, I am Gerardo Viduya, teacher of Ordinata City National High School. Before we go on to our topic, let us recall the expression the quantity x plus p squared is equal to x squared plus 2px plus p squared, which is the quadratic equation by completing the square. Notice that the last term in the perfect square trinomial, p squared, is the square of a trinomial. This knowledge can be used to complete it. For example, find the value of p so that x squared plus 8x plus p squared is a perfect square trinomial. Then after that, you have to write the equivalent square of a binomial. So the numerical coefficient of x is 8. So 1/2 of 8 is equal to 4. Then x squared plus 8x plus 4 squared is equal to x squared plus 8x plus 16. And therefore, x squared plus 8x plus 16 is now the perfect square trinomial. Then by writing it to a binomial square, we have the quantity x plus 4 square. Number 2 example, we have x squared minus 4x plus p squared, where p now is the unknown. So 1/2 of negative 4 is equal to negative 2. Then the square of negative 2 is equal to positive 4. So we have x squared minus 4x plus 4. By changing it to a perfect square binomial, we have the quantity x minus 2 squared. Next, we have the circle. A circle is a set of all points in a plane, all of which are equidistant from a given point. Applying this definition on the figure, where C is the center and the coordinate is x sub 1 and y sub 2, and point P on the circle, the coordinate is x sub 2 and y sub 2. So CP is a radius. Then applying the distance formula, we have now R is equal to CP or is equal to CP is equal to the square root of the sum of the quantity of x sub 2 minus x sub 1 square and the quantity y sub 2 minus y sub 1 square. So let us have C, which is the center, and the coordinate is 0, 0. Then applying the distance formula, we have now the square root of the sum of x minus 0 square and y minus 0 square. Then R is equal to the square root of x squared plus y squared. Squaring both sides of the equation, we have now r squared is equal to x squared plus y squared, or x squared plus y squared is equal to r squared, is the standard form of the equation of a circle with center 0, 0 and radius r. Okay, using a figure where C, the coordinate of C is k, and P, which is on the circle, point P is on the circle, the coordinate is x, y. Consider that point C is equal to x sub 1 and y sub 1, and point P is x sub 2, y sub 2. Then using the distance formula, we have r is equal to the square root of the sum of the quantity x sub 2 minus x sub 1 square and the quantity y sub 2 minus y sub 1 square. Then by substituting x sub 1, which is h, and by substituting y sub 1 equal to negative k. Then by squaring both sides of the equation, we have r squared is equal to the sum of the quantity x minus h squared and the quantity y minus k squared, or the quantity x minus h squared plus the quantity y minus k squared is now the standard form of the equation of a circle with center h, k, and radius r. Okay, using the standard form, then we'll have to square the binomials and collect terms. We have x squared minus 2x x plus h squared plus y squared minus 2ky plus k squared is equal to r. Then we have x squared plus y squared minus 2hx minus 2ky plus h squared plus k squared minus r squared is equal to 0. We have now the general form, which is x squared plus y squared plus 2x plus ey plus f is equal to 0. The general form of the equation of a circle where d is equal to negative 2h, e is equal to negative 2y, f is h squared plus k squared minus r squared. Now, let us now determine the center C and the length of the radius R of each given equation. Activity 1, number 1, x squared plus y squared is equal to 81. So, using your equation where C is 0, 0, we have x squared plus y squared is equal to r squared. Then therefore, the center is 0, 0, and the radius is equal to 9. Number 2, we have the equation x squared plus the quantity y minus 3 squared is equal to 144. Using your standard form of the equation, we have the center hk is equal to 0, 3, and the radius is equal to 12. Okay, number 3 example, we have your equation of a circle in standard form. we have the center HK, so it is equal to 7, 9. And the radius is equal to 5, the square root of. Number 4, the equation is in a general form. So we'll have to transform this to standard form of an equation of a circle. So first, we have to find the additive inverse of negative 11. So we have the equation x squared plus y squared plus 8x minus 6y is equal to 11. Then combine like terms. So we have the quantity x squared plus 8x plus the quantity y squared minus 6y is equal to 11. Then you have to change it to a perfect square trinomial. Then don't forget to add the constant term to the right side of the equation. So we have now x, the quantity x plus 4 square plus the quantity y plus 3 square is equal to 36. Then we can now find the center of a circle, which is negative 4, negative 3, and the radius is equal to 6. Yeah. Activity 2. Write the standard and general equation of a given circle given its center and radius. So example, the center is 2 and negative 8. The radius is 9. Using your standard form, by substituting the value of h and k, we have the quantity x minus 2 square plus the quantity y minus the quantity negative 8 square is equal to 9 square. So we have now x minus 2 square plus the quantity y plus 8 square is equal to 81, and that is the standard form of the equation. Then using the standard form with center HK and radius R, we have the quantity x squared minus 4x plus 4 plus the quantity y squared plus 16y plus 64 is equal to 21. Then we have now x squared plus y squared minus 4x plus 16y plus 4 plus 64. Then finding the additive inverse of 81 is equal to negative 81, then is equal to 0. Then therefore x squared plus y squared minus 4x plus 16y minus 13 is equal to 0 is the general form of the equation of a circle. Activity 3. Determine the equation of the circle given its center and the point on the circle P. So example, the center is negative 3, 2, and the point on the circle is 4, negative 6. So HK is negative 3, 2, and point of a circle is 4, negative 2. Using your standard form of the equation of a circle, we have now, by substitution, we have then R now is equal to 113. Then extract the square root, we have R is equal to the square root of 13. So your equation of the circle is equal to the quantity x plus 3 square plus the quantity y minus 2 square is equal to 113. That ends my topic. Thank you and stay tuned for the next virtual instruction.